Today, we are going to take two coordinates, map them onto a graph, and calculate the precise mathematical distance between them. This coordinate system allows us to visualize complex algebraic equations as physical lines and shapes in a two-dimensional plane. This system is a core requirement for Class 9 entrance exams and Class 10 board exams. Before we begin, gather your materials: a piece of graph paper, a pencil, and a ruler. By the end of this exercise, you will have a finished graph and the specific calculation that proves the length of your line. Let's start with two test coordinates, point A at -5, 7 and point B at -1, 3. Every coordinate is written as an ordered pair, organized as X, then Y. The positive or negative signs attached to these numbers tell us exactly where the points belong. The coordinate plane is divided into 4 sections, called quadrants. This diagram shows the 4 quadrants. Quadrant 1 holds positive X and positive Y. Moving counterclockwise, signs change to negative positive, negative negative, and finally positive negative. Point A and point B both have a negative X and a positive Y. They belong right here in quadrant 2. Mapping the signs first creates a mental boundary. You know exactly where to work, which prevents you from drawing off the edge of your paper. To plot point A, start at origin, move left 5, up 7, and drop the point. Remember, run before you jump. Move horizontally first. For point B, reset, run left 1, jump up 3. Finally, draw a line connecting them. We now have a concrete visual representation of the line segment. Our next step is to calculate its exact mathematical length. A physical ruler is subject to human error. To find the precise distance between these 2 points, we need a reliable algebraic tool. This is the distance formula. It calculates the exact space between any 2 points on a grid. Above your coordinates on your paper, explicitly write x1, y1 over point A and x2, y2 over point B. Labeling your variables directly on the page is the single most effective way to eliminate careless substitution errors during a test. Substitute numbers into the formula: -1 and -5 for x, 3 and 7 for y. Pay attention to the x coordinates. Subtracting a negative becomes addition. Rewriting it as -1 plus 5 helps avoid errors. Now solve the arithmetic inside the parentheses. -1 plus 5 is 4. 3 minus 7 is -4. Square the terms to get 16 and 16. Add them together for the square root of 32. Finally, break down the square root of 32. Since 32 is 16 times 2, and the square root of 16 is 4, we arrive at our final answer, 4 root 2. This algebraic result confirms the exact length of the physical line segment you drew earlier. We started by decoding the signs of our coordinates, plotted them in quadrant 2, and used the distance formula to determine the exact length between them. Compare your graph paper to the correct result. You should see a clean line plotted on the left, matching the calculation on the right. Plot, set up, substitute, and solve. Following this specific workflow consistently will help you handle more complex coordinate problems. You now know the exact length of this line segment. The next logical step is to find the coordinate that sits at the exact middle of this line. We determine that point using the midpoint formula. Join us in the next video to see how to apply that calculation to the graph you've already started.